Okay, so we're going to look at area of quadrilaterals and area of triangles. You should know the area of a rectangle is base times the height. You're just counting those squares, but all this relies on the area of a rectangle is base times height. So what we've got here is a triangle. The base here is 8. You may not be able to see the grid, but 1, 2, 3, 4, 5, 6, 7, 8, and the height is 6. So half of 8 times 6 equals 24. But why do we get half the base times the height for a triangle? Well, if you look at the triangle, here's the triangle. Well, it's always half a rectangle. Now, the obvious case is if we move it right over to this side, that's obviously half that rectangle, an 8 by 6 rectangle. Remember, it is 8 by 6. So what's the triangle? A triangle is going to be half this rectangle. Why? Because we can cut it in half. There it is there. We've cut it in half, and one side lays exactly on the other. It doesn't matter what this triangle looks like. If we move this across a bit, we should be able to cut it into two triangles, one triangle here and one triangle on the other side. And when we split it up, we're back to getting that rectangle. So it all works because the area of a rectangle is base times height. And it doesn't matter what this triangle looks like, it is always base times height. If we look at the parallelogram here, how do we find the area of a parallelogram? Well, it's basically the same as a rectangle. It's base times height, and it is this perpendicular height. In areas, we're always after this perpendicular height. So it's base times perpendicular height. Why? Because we can convert this back to a rectangle. Every single parallelogram can be moved like that to make it from this parallelogram, and we cut off this little triangle bit here, move it across, and it becomes a rectangle. So it's always the same base times perpendicular height from that rectangle to that parallelogram. Another way you can look at it is that here's the parallelogram. What we're going to shave off this little bit here is going to fit up here, and what we're going to shave off this little triangle here is going to fit here. So if you look at that, why is the parallelogram base times perpendicular height? Because that's another way you can look at it as happening. And it doesn't matter what this parallelogram looks like. I'll try to make it a bit weirder. Okay, again, this little triangle here is going to fit right in here, and this little triangle is going to fit up the top. And there you go, you can just watch that. So that's why a parallelogram, and that's what we're trying to do, show you why these rules work. It's fine to know the rules, but if you understand where they come from, chances are you're going to have a better chance of remembering them. Or just saying, okay, I can turn this into a rectangle by just taking this triangle, moving it across, or taking these little triangles. It is really just a rectangle. Last one is, how do we go from and I'll just make this a little bit smaller maybe. Yep. How do we go from this trapezium, and we want to get it back to a rectangle again? Because there is that formula for a trapezium. Area equals h over 2 multiplied by a plus b. But students really find it hard to remember that formula. So it's something to do with the height. Perfect. How do we get this a plus b and divide it by 2? Well, it is just the number between a and b. Basically, it's just the number right in between, because what's going to happen here, we're going to shave off this little bit and put it up here, and we're going to shave off this triangle and put it up here. So we're converting that trapezium into that rectangle. And what have we done? Let's say this is 6 and this is 10. Then the number right in between 6 and 10 is 8. Bang. If it's, say, 4, we'll move this a bit. That's a bit of a bummer. Went off the screen. I don't want it to go off the screen. Let's shrink it a bit. No, we're not going to be able to shrink it either. No. Okay. Um, okay. Let's have a look at this. It doesn't matter how far we move this across. We should be able to move this triangle up here and move this little triangle up here. And what we get is we turn that back into a rectangle. Let's say this is 2 centimeters and this is 14 centimeters. What is right in between 2 and 14? 2 and 8. How did I get that? I added these two things together, this A and B, and then divided by 2. So 2 plus 14, 16, and then divided by 2. So we're really just finding the average of those two numbers. And it doesn't matter what the numbers are, we can make it really small. Say this is 1 and this is 20. How do we find the number right in between 1 and 20? 1 plus 20 is 21. Half of that is 10.5. Or what is the number right in between 1 and 20? Why does it work? We can flick those triangles around. It doesn't matter how weird our trapezium is, we can always do that. Having said that, I actually prefer just splitting the trapezium up into a rectangle in the middle and two triangles and just finding the area by that. And then you don't have to remember any formulas other than the area of a rectangle and area of a triangle, which we've been dealing with for a long, long time. So hopefully that just shows you where these formulas come from a little bit and helps you to do all that. So thank you.